Hello, you are now entering the infinite void. Hang on tight. We cannot save you now.
Hello and welcome to this week's episode. I'm your co-host Matty.
And I'm your co-host Jacob, and today's episode is the Fermi Paradox. So, I don't know if you know much about the Fermi Paradox, May, but essentially it's the contradiction between the size of the universe and the lack of evidence for extraterrestrial life within the universe. Do you know much about it?
So it's something that I'm sort of aware of, and I've sort of looked at in a little bit of detail, but not studied massively. So hopefully it'll be an interesting topic for today.
Cool. So it was created by Enrico Fermi in 1950, who is a physicist, and it basically came around from a conversation that he was having on a lunchtime with some other physicists. So they were all kind of excited, and they were discussing the recent UFO reports, because I think the Roswell crash was in 1947, so that was a few years before. So they were kind of UFO manic in America. And they were discussing the idea of faster than light travel, because obviously the universe is so big. If anything was to come from outside of our solar system, they'd probably need that kind of technology to be able to get here. And essentially, that's why it's a paradox. Everything's so big, and we don't see any evidence for it elsewhere. There have been a few people that have tried to tackle this, and it ranges through loads of different ideas. I mean, you have conspiracy theorists that fully think that they're everywhere and there's different species and all these kind of crazy things. And then it goes the complete other way, where there's literally no evidence for anything. And then we've got stuff like sci-fi, where we've got games, films, books, where it kind of plays with the idea of life from another planet or from the future or from the past. But on a more scientific approach, one of these people that was trying to tackle this was Frank Drake. And in 1961, he formulated the Drake equation. And basically, the Drake equation was created in an attempt to find a systematic means to figuring out what the probabilities were involved for the existence of extraterrestrial life. And it came from things like star formations in the galaxy, fractions of stars with orbiting planets, fractions of those orbiting planets in the habitable zone, and fractions of those planets that can even go on and develop life. And the list goes on. And in a minute, we're going to be going through the equation a little bit. Have you heard of the equation?
Yeah, so I know of the Drake equation and a few of the terms in there. And cool. I'm sure when you come onto it in a bit, it will make a bit more sense. But yeah, it's interesting. It's more of a thought experiment than an actual sort of vigorous calculation, but it's still interesting, and it sort of underpins a lot of this sort of Fermi paradox idea. So
exactly, and kind of like what we know so far. Do you know what I mean? Because we've only got an example for life from kind of like the habitat that we know that we've come from, so it's quite hard to gauge in the future if what people have suggested with even if it's possible to have silicon life or something like that. Do you know what I mean? And what that would require to be alive. But so we'll start it off. So we have n, which is equal to the number of sorry. I got a little bit confused then. I was reading it and I was like, why is the first one the thing? But so basically
it's a long equation.
So the equation is n equals r star times fp times ne times fl times fi times fc times l. And we're going to be going through each of these because they're quite interesting. And as a thought experiment, like you were saying, it can really get the cogs going. But basically, n, which is for what the whole equation is equal to, is the number of civilizations in the Milky Way where they have electromagnetic emissions, so we can actually detect them. And so far, that's 0. But as we work through this, we will see. So R star is the rate of formation of stars suitable to develop life. So we need a star kind of like ours, and there are many of them out in the observable universe that is suitable for developing life. Then the fraction of those stars that have planetary systems orbiting them. Then it's the number of those planets in the solar system that have environments suitable for life. Then it's the fraction of suitable planets that life actually appears in those areas. Then it's the fraction of life that can then go and evolve into intelligent life. Then it's the fraction of civilizations that can develop technology to release detectable signals into space to show that they even exist. And then L is the length of time that the civilization has to release those signals. So obviously if they're quite far away and they release them a couple of million light years ago, if they're like 4 million light years away, it's still not going to got here yet. And we might have evolved past that by then.
Yeah.
So it's a pretty crazy equation.
Mm-hmm.
I've seen a few people online, especially on Reddit, try and break it down and apply like different percentages and argue the debate of what percentage of those sun-like stars might be out there and what percentage of those planets that are like Earth might be out there. And some people have tried to argue that it's as high as 50%, and some people have tried to argue that it's as high as 1%.
Mm-hmm.
There was a study that I found that was done by the PNSA, and they tried to do it at 22% based off the size of the universe and what kind of like what we were looking at. And that basically meant that potentially that could be 1% of all stars in the observable universe. There are Earth-like planets orbiting them, which comes to around about 100 billion Earth-like planets.
Yeah.
And they went further in that and they said, so after 1 billion years in existence, let's say 1% of those 1% Earth-like planets can actually develop life. And that's life that can actually emerge, become intelligent life, and create technology, and so on. That came out at 10 quadrillion planets. And it came out at 10 million billion intelligent civilizations. So it's such a crazy high number, just at like 22%. And you can imagine the higher you go, if the more we learn, there's more planets and life seems to be popping up all over the place, or doesn't take a lot to survive. Because wasn't there a couple of months ago, didn't the India space program like spill a load of bacteria on the moon?
I think it was tardigrades, I think.
Oh yeah.
Which they know can sort of survive in space. So that's potentially a bit worrying, but that is yeah.
So because at the moment we don't really know, do we?
No.
As astrobiology kind of goes, that we've only really got one planet of stuff to look at, and we only really know carbon-based life as well. It could turn out, like we were saying at the beginning, that there could be so many other ones. And basically, they tried to scale this down to our cosmic backyard, which is the Milky Way. And they did the same kind of math again at 22%. And they kept working through it, and it came out that it was anything between 36,000 and 100,000 intelligent civilizations in the Milky Way alone.
Yeah.
Which is pretty crazy because, yes, the Milky Way is massive, but in comparison to the observable universe, it's not. And that's quite a high number to have. But, like Fermi, if it's such a high number, then where is everybody?
Yes. So this is the sort of basis of the Fermi Paradox.
Exactly.
Why do the numbers say there should be, the universe should be teeming with life, but we've never seen any of it?
Exactly.
That is the sort of fundamental point of the Fermi Paradox, isn't it?
Yeah. And there's a few things going on. Do you know of any efforts to try and figure this out?
So I know of the SETI Institute Search for Extraterrestrial Life. Is it?
Yes.
They're sort of looking for radio frequencies from other sort of civilizations in the hope that they'll find something.
Yes, and so far they haven't found anything, which is always good. But another thing to consider as well about our solar system is it's actually relatively young in comparison to the lifespan of the universe and many other solar systems. Our sun there's just far older suns and there's far older planets than what we've got. And when you look at our tech boom, if you want to call it, or would you call it space exploration boom? I don't know. They kind of go hand in hand. In the last 100 years, what we've managed to accomplish is nothing in universe terms and time scales. And when you look at all these other solar systems and stars that have planets going around them that are so much older.
Yeah.
It does create that paradox that of like, well, if there's all these places that are so much older than we are, why can't we see anything?
hmm The other issue, of course, with that is the sort of flip side of that is that it's possible that civilizations did exist, but existed sort of a long time ago relative to us, sort of in space time, and we sort of miss their signals as they've already gone past us or something. So, or they've not reached us yet. So, yeah.
Yeah, I was going to say, I think I saw something about this actually. Isn't because of how far Alpha Centauri is to us, which is that is it a binary or is there 3 suns?
I think there's 3. That's a 3-sun, 3-star system. Yeah.
They were saying, weren't they, that like they would only now just start getting our like World War II radio signals.
I thought they were close. I thought they were at 4 light years. I could be wrong on that though.
I have no idea. I might be wrong too. I saw something that they were just saying how like a lot of the stuff that we've done in like the last 50 years would be reaching place, but I might have got a different place.
Anyway, yeah, it still stands that that they are our nearest stars, and the next ones that are closer than that are significantly further away. So, that still only gives us one little system to look at. But it is a potential issue of you're trying to constantly fight this idea that things are relative in time. So things that were happening millions of years ago, we're potentially looking at when life may just have been evolving, and now life on that planet is sort of well developed. But that's potentially something we'll come back to later in the episode.
Well, that's it. We're kind of like taking a very human approach to it as well. Like with all of those like possibilities, we're doing the idea of like what we would consider life. So we're kind of just like basically doing it for if we could find humans out there, kind of thing.
Yeah.
But as we don't know, we really have no idea the full scale of it, because it would be like grabbing a teaspoon and going up to the sea, taking a teaspoon of water, having a look at it and being like, well, we can't see any intelligent life in this teaspoon, so there must be no life in the sea.
Yeah.
But
I guess the other thing to consider while we're just on the topic of talking about like trying to receive and see signals is what's to say that these sort of signals aren't things that we're familiar with. A sort of another civilization could have a communication technology or method that we can't see. It would be like trying to talk to an animal that doesn't have ears, sort of thing. So
exactly.
So that's sort of something else to sort of bear in mind as well. We're on the topic of sort of a human-centric approach.
If we assume everything's like linear and like every civilization gets radio or so on, kind of thing. Because it's like you said, it could even be something as crazy as like their planet doesn't have the same resources that our planet has, and they don't have the ability to build the infrastructure for like radio and stuff. But
so
it's pretty crazy. I found a quote on the SETI website, and I thought it was pretty good, so I saved it. But it basically said, Fermi realized that any civilization with a modest amount of rocket technology and an immodest amount of imperial incentive would rapidly colonize the entire galaxy within 10 million years. Every star system to be brought under one wing of the empire. So I thought it was kind of funny. And that's scary because, like, with the idea of, like, 10 million years sounds long, but that's still not long in comparison to, like, how old the Milky Way is. Do you know what I mean?
Yeah,
and even our planet. And for it to take that time, if it had that technology, do you know what I mean? Because these start to like push on topics like the Kardashev scale and stuff, which we're going to talk about in the future, or like the Great Filter. But if you can like assume what we've managed to achieve in like the last 100 years, or even since we've been around, like that's not that much time. And like imagine what we could be able to do in the future.
Well, I think as you said earlier, we do only have sort of one sort of case study for life in the universe, which is ourselves. But you can see how rapidly things can develop once you get over just a few you get a few basic technologies. Humans have been around for about, I think, 20,000 years or so. About sort of 5,000 years ago, we started to develop modern civilizations, like the Egyptians and things. When
exactly.
That's when you can start to say, what we would consider properly modern humans developed. So it took 15,000 years to get to that point. Then we've had another 5,000 years where we've just really started to develop cities and things like that. And then in 100 years, we've gone from a largely sort of agriculture-based society to having all the technologies we do have. So I can quite imagine that in 10 million years, you can go to a galactic empire from where we are now.
Totally. It's funny because it's like my dad always used to watch it, so as a kid I was totally down. But it's kind of funny because it's kind of like Star Trek. It's kind of going to be the way that it goes. Do you know what I mean? They'll just be like a galactic. If we want to call it empire, it might be something nicer, but whatever it's called, there'll be the galactic thing. And what happens if it's something as ridiculous as like you've just got to get to a certain level of understanding? Do you know what I mean? And then it's like, because like, isn't in Star Trek the whole like point of it is you've got to get to you got to invent like warp drive or something, and then you're allowed to join. It's like, imagine if it was just something as simple as like being like, you have to like be 100% renewable and just like be able to survive without like using anything, and then you can join, kind of thing. And that's what it all is. But
yeah, just to bring it back to sort of one, this is something that really bothers me about this whole debate is the quote you just gave about this. Can you just repeat that quote for me?
Yeah, sure. So it was, Fermi realized that any civilization with a modest amount of rocket technology and an immodest amount of imperial incentive could rapidly colonize the entire galaxy within 10 million years.
It's that second bit about the immodest amount of sort of imperialism. It's a very human-centric mind point to think that any sort of life form would just naturally want to take over a galaxy.
Exactly.
It's entirely possible that another sort of life form would get to where we are now and would go, oh wow, this is great. We've got everything we need on this planet. We're just work on making it better for ourselves and live on this planet for the rest of our lives in utopia.
Exactly.
It's a very human-based approach to think that we'd go out and colonize other sort of planets and star systems and things. So
yeah, I totally agree with you. And like, without going into it too much, because this could be a whole topic as well in the future, but even like, look at where we're going with like our technology, our simulations and our VR. Do you know what I mean? Like, it might be better to be on one planet and simulate whatever you want instead of having to go on insanely long journeys through interstellar space to try and find somewhere else to live. Obviously, you have to do that if the planet's gonna completely go down the pan. But if you can be renewable and everything's good, then you don't really have a reason to leave.
Yeah, well, this is one very interesting idea that I sort of have heard about in this sort of context. Is you can imagine us in 100 or 200 years, we start to sort of get out of our own planet and sort of go to other stars, well, even other planets or other star systems, sorts of things. It's entirely feasible that instead of sending us to begin with or ever, that we would just send one probe with some sort of receiver and, I don't know, a 3D printer, these sorts of technologies on it. And then we just beam information at it and build a civilization and mine things just sort of electronically without sending people at all, or really building much there in a way of infrastructure that we would see.
Yeah.
So
I think I've seen like quite a dark approach to that. Somebody suggested like the idea that you could send a probe, like you could put them on light sails, send them out into interstellar space at like insane speeds, and then just have the probe copy itself when it gets there using the resources of the planet. It was like quite like a dark idea of like this like mechanical digital virus that we could create, and it could just go and like mine like the entire universe if you're given enough time. Just gets there, multiplies, and just keeps mining everything for us.
Yeah. It does sort of seem that, I know we're sort of discussing it now, but this whole argument is sort of it's almost based in the past on this idea that I guess sort of like, you know, like the 15th, 16th century, that we would send out ships and we would colonize places with people, and that's how we do it, when reality is that's a model that's 500 years old. It's not. Well, it's not maybe the future.
Yeah, this is it, and you can see it in like Hollywood and stuff as well. Like in the Alien film, whenever the alien shows up, he's just always like, they're always the ones that just destroy the planet. Do you know what I mean? And like humanity has to come together. Or when people like talk about the idea of aliens, it's like they'd only be coming here for one reason and all this kind of stuff. And it's just like, no, I feel like that's just more of our like colonization guilt that we have from our history. And it's kind of like, well, because we were more advanced and we went to these places that didn't have anything and we just took over. That's what would happen to us if something more advanced showed up. But like maybe we're not even considered intelligent life and we just think we are, and actually intelligent life is like knows better than to do that. Do you know what I mean? And we're just sitting here coming up with this entire idea that this is what you must do, and like actually, nah, don't.
Yeah, it is this sort of human-centric approach, I think, that sort of creeps in. And it is down to the fact that we only have one sample, which is ourselves. You know, it's very difficult to think in a non-human way, that sort of way. So, yeah.
It is interesting.
Yes.
But without going into it with too much detail, because there are a few things that I wanted to talk about to do with the Great Filter, but I'm only just going to touch on it a little bit because I feel like we should do an episode. But it can be, just for anybody that's listening, it can be as crazy as jumping from single cell life to multi-cell life, or that technology becoming viable for the planet because the civilization could destroy itself. Like, the possibilities are endless for why we don't see anything or why it's not there anymore. But I don't know, I just find it a really interesting thought experiment, because like when you sit there and you like actually start breaking down the equation, like you just don't think about those things.
Yeah.
Like I was talking about it to my mum just because I was like running through some of the stuff to see what she thought, and like bless her, she just had never really had an interest in space, never really thought about it, kind of thing. And we were just sitting there talking, and I was like, rate of stars, and she's like, what do you mean? And I was like, Mum, you do realize like all the stars in the sky are like suns? And it's like, oh whoa, that's insane, kind of thing. And it's like, yeah, and like it's just it's crazy. Like the universe is just so incredibly big. And we just seem to be finding more and more out about it. Do you know what I mean? Like we've recently done that exoplanet survey, which was like 4,500 planets orbiting stars. And it's just funny because like you talk to like my grandparents and they were taught a solar system, and that's all there was. And then you go back like a couple of 100 years and the Earth's the center of the solar system, or the universe, or whatever they were calling it, and everything rotated around us.
Yeah. So this actually nicely brings me on to my sort of something I wanted to discuss about this, which was the idea of sort of pushing our knowledge forwards. And if you look at the Drake equation, it sort of seems like I said earlier, it's a bit of a thought experiment. We don't have actual numbers for these things. You know, when we say, what are the fraction of life forms that are intelligent? Is it 1%? Is it 10%? Is it 50%? We don't really know. But we do seem to be sort of going down the Drake equation, gradually ticking things off as we find them. So, you know, sort of decades ago, we didn't know that the stars were other suns. And then we sort of found out that one. So that gives us our sort of rate of star formation, the sort of number of stars, the number of other star systems. So, you know, tick that one off, and then you get to the sort of exoplanets which have come about in the last few decades. You know, so the fraction of exoplanets where we could tick that one off. You know, we have I can't remember the name of the survey now, but you know, we're basically just cataloguing as many as we can, and you know, finding out that they're not really that rare, and they are quite common. You know, so the next one would be the average number of those planets that can support life, and we're just getting to the point now where we can, you know, sort of see the atmospheres of these exoplanets, and we're starting to find planets that sort of have oxygen, which we would usually associate with life and things. So, we're just ticking off that one.
Yeah.
So the next one, sort of, if you go down the list, would be the fraction of planets that sort of go on to support intelligent life. So maybe sort of just thinking about that would be the next step.
Yeah.
So it's quite interesting that over sort of decades and centuries, we've gradually gone from knowing nothing about the universe to being able to sort of put some relatively well-defined numbers into this equation and get more of an idea on it. So.
And if it goes the other way and we are alone,
Mm-hmm.
or the first, that's pretty crazy that it's got this far. Like life evolving from what it started as to this intelligent being that can like understand not its full place in the universe, but like where it's at least located and like what's in its vicinity.
I sometimes just get quite existential about this. You sit and think, I am literally just a collection of atoms that happens to have fallen into a blob that is able to do things like this podcast and
exactly to
look
even
at
be
the
able to
internet and
talk about
stuff.
it. Yeah,
it's crazy.
it is crazy. It is crazy, especially because of like just as well the lack of evidence that it happens anywhere else. Just makes it even more crazy. Like, why is it here, and why am I a part of that?
Yeah, exactly.
It's pretty nuts.
Mm-hmm.
It is, but no, I think I don't know. It's just one of those things because you can sit there and you can talk about it forever. Do you know what I mean? Because I mean, what sparked it for them was just the whole idea of the UFO reports, and like for me, I haven't seen anything that makes me go, "Yes, they're here." Yeah. Do you know what I mean?
Yeah. What's your gut feeling? Do you think there is life in our galaxy, and that we will find it within a reasonable, maybe not our lifetimes, but in the next few hundred years, say? What's your gut feeling?
I fully reckon that there is,
and
I think that there's going to be more than one as well. I think that there's going to be like a few different like intelligent races. I think over like the next 200 years there'll be like a couple. I don't think it'll just be like humans and then like one other that we found kind of thing. I reckon when we find one, I reckon we'll find like a couple of others, and they might have known about each other or for a little bit longer or whatever. But I think we will. I 100% believe it. We have to. It's so big. It's like the chances are just too much in its favor. Like it's too big. There are too many. There are too many opportunities for it, and I think we're too. It's being too human to think that like we're the first or we're the only ones. Do you know what I mean? I think if anything, if it's going to go anywhere, I think it's more so that we're like last to the party than we're the first to the party kind of thing.
Yeah.
But I don't know. What about you?
It's very, very difficult. My gut feeling is that there almost certainly is. And if we were able to find sort of strong evidence of any other life, sort of even microbial life, that would be the final sort of step for me. I don't think it would be conceivable that any life could exist somewhere and that no other life has managed to get sort of intelligence.
Yeah.
That would be the step for me. If someone, and I think probably within our lifetimes, we will definitely see that sort of signature of life. Sort of confirmation of life on other planets and things. And if
go on,
carry on.
I was going to say, so you don't think that we'll see intelligent life in our lifetime?
I wouldn't put money on it that we would see intelligent life.
That's fair. Well, it kind of always it's seemed that way from the beginning anyway. Like even since Roswell, like how long ago was that? 50 years. Even if that's true, and you have this whole idea of like disclosure, and we're finally going to know kind of thing what that was, and if it was kind of thing. It's like just never seems to happen. It's like over these like another 10 years. So we got to wait. But I know that the New York Times put out those videos, and you've got that Air Force pilot, haven't you? Commander Fravor or whatever his name is. And the video looks cool, but like again, it's like you got to show me the actual photos, and why is it always a low quality 30 frame rate?
I don't think aliens have been to Earth. I don't buy into that for 1 second. But I would.
Well, that was going to be my next question. Do you think it's possible also that if there was life in the universe or intelligent life, and it has been here, it just came here long before we were ever here, and we just weren't here, so it didn't need to.
Yeah. Well, this is actually one thing that I was going to say was, I know we said earlier about the sort of human-centric approach to all of this, is that we seem to swing sort of one way or the other on it. Either we seem to think that we're incredibly rare and that, maybe there's no other intelligent life or life at all, or we seem to swing on the side of, we're very common, or that we're sort of last of the party sort of thing.
Yeah.
What if we were instead just completely average? Just imagine that, identical humans had evolved at exactly the same time. That's very unlikely, but just if you take us as average, that would be the case.
Yeah.
On a nearby star. We wouldn't know about them because we don't have the technology. They wouldn't have the technology. And I think SETI said we can only accurately see sort of radio frequencies, general radio frequencies, so not sort of directional stuff, but sort of like our radio stations that just happen to go out into space sort of stuff.
Yeah.
We would only be able to see those out to about 0.3 light years, which is not anywhere near our nearest star, with the technology that we have both on receiving and transmitting. So if you were going to say that humans are average, then you wouldn't expect to see us because we would all just be evolving now, sort of getting to this stage, doing our own thing completely independently. So
yeah.
So what was your question that you just asked me? I went all up on one.
No, that's the point. That's the point, because it would be like everybody's walking around right now with infrared on their phones and they can't see anybody. Do you know what I mean?
Mm-hmm.
You're not touching each other with your phones. It could be like that. Do you know what I mean? Because like you're saying, the universe is so big. Even if people are all at radio, we're still kind of too far where we've both had radio long enough to be able to see that.
Yeah.
That would be a mind-blowing thing. Imagine if we did discover intelligent life elsewhere, but it just turned out that we just discovered other humans, and that it was humans were the said thing across the universe.
Not necessarily like exactly humans, but just something that happened to evolve at the same time as us on their planet and had the same sort of growth pattern as us. Because, and I think that's a possibility that probably doesn't get discussed. We do tend to think either we're fundamentally unspecial, or that things would be fantastically better than us and would have all these amazing technologies, or that we're exceptionally special and that we're the only ones with these technologies. It's entirely possible that they have sort of similar sort of advancement to us, and so we just don't find each other because we're both average.
Yeah, totally. And like if you look at like the vast different amounts of life here on Earth, maybe like all of those kind of things are just life, but on different planets, different ones get the evolutionary like kick. Do you know what I mean?
Yeah, but I've never really thought about that. If we were
like the mammals were just the priority for planet Earth, and maybe on a different planet it could be someone else.
Yeah, but even if we were different mammals, if we were dogs right now, we wouldn't be thinking, oh, what about life on other planets? Because it would be completely beyond our sort of scope of thinking, because it's not sort of something that we experience. But yeah, there's so many sort of rabbit holes you can go down, and most of them with you questioning your own existence.
Exactly. And like humans not that long ago didn't even know that there was space. Do you know what I mean? So they wouldn't even been asking the question, like you were saying. If we keep going all like further and further back, like we're just slowly, it's like we've been able to like realize the question, and then over the decades and centuries we've like been slowly ticking them off. There's so many things that it's sort of beyond science at this point when we start to get into these ideas. It's philosophy of what sort of are we and what other things could be out there, and I think you sort of asking questions that are not human to answer in some ways. For a freaky concept, because it's kind of slowly already happening here. We're all cyborgs. Maybe the next step for like intelligent life is computer based. Augmented realities and uploading consciousness, downloading consciousness, and going fully out there.
That it's entirely possible. We've seen with Elon Musk Neuralink, we seem to be just on the sort of doorstep of being able to sort of enhance ourselves and become biologically integrated with technology and sort of computing. So, maybe other civilizations and things have sort of said, oh, let's just go digital and we can all live in our digital utopias.
I saw something, I can't remember who wrote it, but like one really cool idea was that like currently right now, the time of like the universe we're in, it's not ideal for like some energy conservation or something. I don't really know what they were saying, but basically an intelligent civilization, if they had gone digital with like AI and stuff, one good idea for them would just to be like shut off until the universe heats up again. If it like crumbles or something, and they might just turn back on in the future. But it's just crazy. Yeah, because like you can see on Earth it going in so many different directions, and then that widely changes the Drake equation possibilities. Do you know what I mean? And like the whole idea of the Fermi Paradox, because you can go the tech route, you could go the route where you stay on your planet because everything's fine and you found a way to make everything work and nothing's ever going to change, and you've got asteroid protection or whatever you want to call it, and you just know how to look after yourself. There's no reason to leave. But it is weird that like we can't see anything, or like the remnants of anything, or the traces of anything, or like just the pollution of another civilization in space. Because like with our first episode, we've not done a great job of that on our planet, and it's just it's just weird that like we don't see anything else doing that.
But I sort of just to bring it back to this idea of perhaps we've missed them. Things do decay very quickly on the cosmic timescale. We said in our first episode that sort of space debris up there for usually tens of decades before it succumbs to sort of air resistance and stuff. How many things on our planet are more than 1,000 years old? We've got the pyramids and a few sort of Greek ruins and stuff, and that's really about it. Things do decay very, very quickly, assuming, of course, you have a planet like Earth. But yeah, true.
But then I guess as well, like if you look at the Kardashev scale, imagine if you had like a civilization that had just mastered itself so far up that where it was like building Dyson spheres or something around like the sun. Do you know what I mean? And had like full capability of that. Like it's just mad that we don't see anything, or we haven't seen. Like imagine that if we just saw like a star in the sky go out. It was just like that finally reached here kind of thing.
Yeah, you do occasionally get those weird ones, don't you? With the one I've probably seen it a couple of times now is they find a star and they're looking at exoplanets and there's like a dip in the solar sort of profile, and they say, "Oh, this is evidence of some sort of massive alien construction project that's going around because it's not a planet, it's not an asteroid and stuff." You do occasionally see stuff like exactly. If we found one of those, that would be game changing, wouldn't it?
Yeah. And can you imagine if it was old as well?
Yeah.
Just anything as big as a planet that's a couple of billion years old, it'd blow everybody's little minds. No one would know what to do. They'd be like, something has built something the size of a planet and it's billions of years old.
Yeah.
Because that's another thing too as well to like consider. If like elsewhere it might not be like our timeline. Do you know what I mean? Like it might not be like everybody develops radio at the same time, or everybody develops electricity at the same time. Do you know what I mean? Like civilizations could be millions of years off from each other based off when their like solar system formed.
Yeah,
or
exactly.
Their planet became suitable. Do you know what I mean? So like it really is a lottery. But I don't know. I would love in my lifetime to find out if there was intelligent life elsewhere in the universe. It would be awesome.
It would be one of the greatest things. It would be the greatest scientific discovery ever. I imagine that would be it.
But there's that whole idea then as well, isn't there, that people wouldn't handle it. It would wreck a lot of stuff.
There's always this debate about if the government or scientists did find life on another planet, would they tell us about it? And would we want to know about it?
Yeah. It'd be interesting because it brings up the whole question of like what you do with your life. Do you know what I mean? And if we found out like there was a civilization somewhere else in the universe that was doing it differently to here, but they were so much more advanced than we were, you would be sitting there in your day job just kind of like, what am I doing? Do you know what I mean? Like they're doing crazy stuff.
Mm-hmm.
And it probably would shake a lot of people's worlds, especially if they came here and they were like, "We know more about you guys than you know about yourself."
I think it would fundamentally change our place in the universe. You know, life would never be the same again, because I think it's sort of an inherently human question to sort of ask whether we are alone or not, and sort of what we are. Yeah.
It's a funny question because it literally goes two ways with people, doesn't it? You get the people that are like, kind of like, it's cool. I like the idea of life being elsewhere, and like it kind of has to be, right? Even if it's so far away that we'll never see it, like it's so big. And then you get other people that are like, if it's real, it only means one thing. Like we can't get along, and it's like, that could just be humans.
Yeah. I think. It is interesting when, you know, in our current sort of level of evolution, it would be very, very likely that any civilization that we sort of found would be much more advanced than us. You know, just by the nature, particularly if they came here or sort of made contact with us, it would show a level of sort of advancement that we just don't have, because we just don't have those technologies at the moment. But yeah, there's always this idea of, you know, maybe they wouldn't come and, you know, maybe already we're just like some little science experiment to sort of this higher up civilization, and they're just sort of studying us and
seeing what happens, kind of thing.
Yeah,
totally. It's weird to think about because you're right. Because like another way of looking at it is, if we were the galaxy-faring civilization and we came across something similar to humans, but let's say it's not humans, but it's everything that humans have got, you would kind of be like, ooh, do we get involved or do we just leave them to it?
Yeah.
Because right now they're also at a bit of a dodgy step too, for it seems like they're destroying the planet. They can't even get along with themselves. There's so much like divide and everything. It's like, yeah, we'll probably leave them alone for a little bit.
Yeah, or we'd enslave them and
we'll just get rid of them.
Yes, there's so many sort of questions and things that you can ask with this, which is, why I think you've already said we're going to try and do a second episode and look at sort of some other aspects of this in the future, which would be interesting.
Yeah, I think that pretty much wraps up the Fermi Paradox. Like you said, in future episodes, we're going to look at the Great Filter, and this also kind of ties in with simulation theory as well. And I think it'd be good to do episodes on then. So, should we move on to just news and stuff that's been going on in the week? Yeah,
I think so. Where do you want to start?
Wicked. I don't mind. Do you want to go first, or?
Actually, yeah, I will go first because I've got a bit of follow-up news on last week's episode.
Okay.
So, at the end of last week, I said about the Chinese space plane that was being launched or had been launched then. And, I sort of left it a bit open because not a lot was known about it at the time. What seemed to have happened was that China had launched something into space that was like a plane. And I think it had come down then, but certainly at this point now, the sort of update is that it has returned to Earth after spending a bit of time in space. And also, interestingly, I think perhaps NORAD, but some sort of space surveillance group, have tracked an object that has been released by this space plane and is still in orbit. So, still a bit open, but it seems that China has successfully launched some sort of spacecraft that can return to Earth, and has also cargo dropped something into orbit.
Interesting.
Yeah, so that I didn't really have a massive amount to say to it, other than it was sort of interesting follow up last week.
Yeah.
The sort of stuff that I am seeing about it is they're suggesting that it could be some sort of experimental spacecraft that they're using to test their capability on this new sort of space plane. Because I think for a couple of years now they've been trying to sort of generate reusable spacecraft in particular. And I know I said last week about them sort of becoming a real force in space exploration and this sort of area. So
they build.
Yeah.
Well, this would be great for them, wouldn't it? If they're trying to get their space station up, they can just fly up into orbit and drop parts off. It'd be much cheaper than them doing like individual launches.
Yeah, I hadn't actually considered that, but it's definitely interesting, and I think I think it's good that other sort of nations are sort of developing space capability. There is obviously some concern by some people about what this could potentially lead to or be used for.
Yeah.
It's a bit of a difficult one, especially with China obviously being so secretive. I think that's all I had to say about that, really. Unless you had anything to add on that.
No, I think that's cool. It's like you said, I hadn't really seen much about it since we talked about it last week, but that's cool that you'd found that. My news is pretty depressing, if I'm honest with you, because as you know, the world is on fire.
Mm-hmm.
I don't know.
Literally.
Yeah, I don't know. I think you must have seen these photos, and anybody listening, you must have seen these photos. There's just, and if you're in California, then I send my best wishes to you, because it's just horrible. It looks like the film Blade Runner, or like A Day on Mars. Do you know what I mean? It was such a orangey dark red color, but kind of going away from that a little bit. But mine's still kind of depressing. So the BBC was saying, have reported that Europe have basically come out, and the EU's Environment Agency, EEA, have now said that 1 in every 8 deaths is linked to pollution. Which
I could quite imagine that.
Yeah, it's not surprising. And this heat map from January, which is obviously just before I think lockdown and everything went down. England looks like a very big contributor.
Yeah. Well, yeah, obviously it's the sort of, I would say, industrious nations that are sort of causing most of this problem. And I think the sort of particularly sad bit is it won't be those nations that are massively impacted by it either. This is the sort of biggest thing about climate change, is that it's not a localized issue in the way that some things, other things are, you know.
Yeah. Well, it says here the highest is Romania. That's 19% of deaths are linked to air pollution, and then the UK is 12%. But yeah, it's like you said, it doesn't just affect that country, because the whole world's gonna heat up, and that kind of leads into my second bit of news, which is also quite depressing. Woo!
Oh, keep it light.
Basically, I don't know if anybody has been keeping up with the whole climate crisis and the idea of how many degrees we can go up by. But we kind of had a limit of going up 2 degrees a couple of years ago by 2024. And now we are dangerously coming close to passing the 1.5 limit that we put on ourselves 4 years earlier than supposed to be. So that's great. I was reading something a couple of days ago that it's going to be irreversible soon.
Yeah. That, just while you're sort of looking that up, the one terrifying thing that I saw this week sort of related to this was, I know you said about the sort of impact of coronavirus on emissions and stuff, was that a group had sort of looked at the impact of the lockdown on emissions and pollution, and found that, I think it was this year or maybe that 6-month period, emissions were down 6.8%, I think,
Yeah.
on sort of the previous year, which is great, obviously, if we weren't all stuck inside. But that's beside the point. But that is still less than, I think, the 7.9% yearly reduction that we need to reach this 1.5 degrees change. So, just think about the massive impact that we've had over the last couple of months, flights and sort of people going to work and stuff. That still is only about, sort of 80% of what needs to be done to reach this 1.5 degree temperature change, which is absolutely mad when you think about it.
I know, and then you see all like these companies saying that they're going to be like carbon neutral by like 2050, and it's like that's too late.
Yeah,
you can't be going neutral in 30 years.
Yeah, this in 2050. I don't know where it's come from. It seems to have been. I think what's happened is that governments have said, "Oh, that will be a nice round number, and will be a achievable goal that we can reach without making ourselves look bad and having a massive impact on ourselves at the moment." So, yeah, it's pretty terrifying all around, to be honest. Yeah.
Yep. And we'll be around to see it.
And you were saying that they think this is now non-reversible, did you say?
Yeah, so I think either we've already passed it or it's this report, but basically the 2-degree warming limit by 2024, they came out with that I think a couple of years ago. But basically we've gone up 0.5 degree in like a year, and they're warning that we're only 1.5 degrees hitting the limit that we put on ourselves for in another 4 years before it's like irreversible. It's from 1985 this first began, but basically the graph is just that straight up. And that's quite a depressing little thing. So anybody listening, whatever you're doing, if you're driving, if you're chilling at work, if you're running, I hope that made you happy.
Yeah, I'm sure at some point we're penciling an episode to talk about this a bit more, sort of climate change and stuff. But we almost certainly will do that at some point. So
totally.
If anyone actually, I guess, sort of a bit of a shout out, if anyone sort of has any ideas about that, then feel free to send them in. We can talk about those when we get to that episode.
That'd be awesome.
So,
any ideas, hit us up on Twitter, Instagram, or the email, which I think is theinfinitevoidpodcast@gmail.com. But send in your ideas. But have you got any more news?
So the other bit of news that I had, a bit more positive, I guess, was on Nikola, which is a sort of they get a bit of a bad press, to be honest, from Tesla fans, because they seem to just be ripping off Tesla. When you go search on like Twitter and stuff about Nikola, it's just a lot of people saying that it's budget Tesla and sort of thing. But I think last week now they struck a partnership with GM so General Motors, which are a massive sort of player in the car industry. They struck a partnership to produce new trucks, effectively. And Nikola's.
I was just going to say, I did see their stock go up.
Yeah, massively went up on the news. But Nikola's a very, very interesting one. And I think it's fair to say that they're sort of, with their electric battery technology, they are sort of not copying, or I'd say copying, but sort of hanging on the coattails of Tesla a bit in that way. Obviously, a name sort of goes with it as well. But perhaps more interesting and sort of related to this news is their hydrogen technologies.
Yes.
So Nikola is coming at it from a perspective of trucking rather than sort of general sort of vehicles for the general population. And that opens up hydrogen as a very, very sort of competitive resource, because hydrogen is much, much more energy dense than batteries.
Yeah.
And on a big sort of truck where you're shipping things across the country, this is particularly relevant for the US, where you could be shipping things 1,000 miles.
Yeah. When
you're shipping things those sorts of distances, this sort of energy dense hydrogen really sort of comes into its own. I watched a video, I think by Real Engineering, is that called, on YouTube? But yeah, if you search sort of Nikola hydrogen trucks, you'll find it sort of about this, and their sort of approach to things is really interesting because the one thing that has held back hydrogen and why battery technologies have taken off is the infrastructure required for fuel distribution.
Okay.
You know, so with Tesla and electric vehicles, the distribution network is there already because it's the mains. You know, as long as you make sure you have enough sort of power on one end and you have the ability to sort of plug in at the other, then you're pretty much there. But with the hydrogen, obviously, you know, just imagine if we tried to build every petrol station in the country and sort of set that in sort of infrastructure up. But yeah, with the trucking stuff, a significant amount of trucking in America, this sort of was based around, is what they call single route. So it's not like sort of going between lots of shops or going between lots of houses and dropping off. It's a massive shipment going from a factory to a distribution center, one route. And what it means is that they can just put one or two, maybe 3 or 4 sort of filling stations along that relatively easily, get people converted to hydrogen on that route, get these sort of shipping companies that are using that route to use these trucks just to run back and forth on it, use that revenue, and then open up another route, and then another route, and then suddenly, by pursuing these sort of simple point-to-point trucking routes, you've then got a network of fuel sort of stations that can be used for more complex routes or for general vehicles. So although they get a bit of a bad press, I just sort of wanted to talk about them. But they seem to be doing something quite different in this hydrogen market, and you know, they have actually got sort of commercial vehicles now doing actual deliveries with, I think it was maybe Coors or Heineken or some beer company, because this sort of long distance heavy product is sort of perfect for starting out on this this sort of route to hydrogen. So hopefully that's something that will take off, I guess, as another alternative.
Yeah. And like we were just talking, anything that helps with the whole climate crisis is a good thing. The quicker we can shift off using petrol and diesel, I think the better.
Yeah. But yeah, I think it's a sort of an interesting one. And I know they get a bit of a bad rep, but they seem to be doing things quite differently. So yeah, that's, I think, all I had on that one.
So we've got one more pretty awesome thing that has happened today, and we decided to add it in right at the end of the episode because, you know, we can't not talk about it. We've just done an episode on the Fermi Paradox, and today they've found links or possible evidence for the idea that there could be life in the atmosphere of Venus. And basically, from what they announced, they found phosphine, right?
Yeah, so this, I swear this wasn't planned. This just happened to come out today, and we just happened to be recording. But this is potentially massive news because phosphine, as you said, is a sort of signature gas on Earth, at least, for organic life. You know, that is where phosphine is produced in large quantities on Earth. So they're hoping that this sort of signature on Venus, it was in the atmosphere on Venus, not actually on its surface.
Yeah, it was 30 miles up. Yeah,
so they think there could be some sort of, well, maybe microbials a bit for a far stretch, but some sort of colony-like microorganism living in the atmosphere of Venus, which is obviously massively interesting.
Yeah, especially as well because the atmosphere doesn't have any water, does it? It's all acid, I think. And
yes,
the temperature as well.
Acid.
Oh, there you go, and the temperature. But
yes,
isn't there a microbe that lives in those like salt flats on Earth that's in like a very acidic?
Yeah, so there are these sort of organisms on Earth that live in very harsh conditions, but I think they said that even things like amino acids, you know, not life forms, but the basic building blocks of life forms would sort of be killed, not killed, they're not alive, but would sort of break down in the sulfuric acid environment in the atmosphere. So yeah, I think they were quite keen to stress that they have not found life on Venus. They have found something that is a hallmark of organic processes.
Yes.
So.
Yes, it was funny watching the video on YouTube. They were. I don't know. Did you watch the bit when they had everybody asking questions at the end?
Yeah, I did. I did watch the press conference.
They had to like keep stressing, didn't they? They were like,
mm-hmm.
they're like, it's not that we found life, but we found something that can be a byproduct of life.
Mm-hmm. But watching the press conference, I was obviously I was excited about it and stuff, and I knew they would. Obviously, it's a major release; they'd have done their sort of research and made sure things were done properly, sort of thing. But they seem to really drill down into the possible sources of this phosphine. So they said that they found it in quantities of, I think, 20 parts per billion in the atmosphere, which doesn't sound like a lot, but I'll take it from then is significant. And they sort of went through this list of other processes that can produce it. So I think there was sort of chemical reactions. That's an interesting one because phosphine does exist in quite large quantities in Jupiter and Saturn. And that's just a sort of chemical process that results from their sort of vast pressures being them being gas giants and stuff. But they sort of drilled down into that and said, no, it's nowhere near capable of producing these amounts. And they sort of looked at geological things, and lightning was another. And
volcanoes,
they sort of said
stuff like that.
Yeah, I think it was the volcanoes. They said the modelling, it would come out at only producing, I think, 1 part per quadrillion in parts per quadrillion in the atmosphere. So you're talking, millions, of times outside the remit of what has been observed. So they seem quite confident that this phosphine has come from an organic source at the moment. The only other explanation they said would be some sort of chemistry or geology that is unknown on Earth, which would be interesting itself, not quite as interesting as life, but they seem pretty confident that this is not some generalized process and it is a result of sort of biology.
What a job title as well, astrobiologist. That wouldn't have existed like 50 years ago.
Oh, that'd be fantastic, wouldn't it? The people they had announcing it seemed like they said it was almost completely it was sort of completely random that they sort of came together, that apparently phosphine is not a well-studied thing, and they just happened to sort of meet and find sort of other people that were looking at this. So.
Can you hear my cat?
I was wondering what that was.
Yeah, my cat has started meowing. She did this last week for anybody listening. It's about the same time. I don't know. She's weird, man. She gets into routines. Once I start like doing something, she'll like pick the same thing to do at the same time. So like last night I was like playing my PC and she came at this time around 9:10 and just started meowing outside my door because she's not allowed in because she wrecked my chair last time. But hey ho.
Yeah. The other interesting thing, I know they closed on it, they touched on it a bit in the press conference, was the idea of what would be the follow-up to this research and possibly sending sort of spacecraft to go and study this sort of thing. So
I was going to say that it's really cool because Rocket Lab a couple of weeks ago announced interest in going to Venus, and their propulsion system that they're using, I don't know the math or the specifics behind it, but they've announced that they've got the capability now to get to Venus, and they announced that a couple of weeks ago. And then on that press conference I was sitting there and I was like, Rocket Lab, and then they asked them, didn't they, and they were like, we're in discussions with Rocket Lab at the moment. And I was like, awesome, because I think it's only Russia, isn't it, that have actually managed to take photos of the Venus surface.
I think it was called Vega, and it was quite a long time ago. I think it was the 80s. I think it was a sort of like weather balloon that they managed to get into the atmosphere. So, I think there's sort of potential questions now about for sort of organisations like NASA about what they sort of prioritise, because over the last few years we sort of started to move towards I know Europa's one of massive interest, and Enceladus, these sort of like watery moons as potential areas for life.
Yeah.
But I imagine that there'd be quite significant interest in it just because it would be easier to get to Venus, and could be done quite cheaply. A weather balloon sort of dropped in the Venetian atmosphere would be significantly easier than some submarine on a dune of on the moon of a sort of another planet. So yeah.
Aren't they building something like that? I swear that they're building like a underwater drone that they want to send to. Is it? I don't know which one it is. It's one. I
can't remember if it's Europa or Enceladus, but yeah.
Yeah, they want to like drill into the ice, don't they? And then have like a water drone there, which is just crazy. Yeah. It's awesome.
Yeah. The other one, I know they had a plan to. I think it's Enceladus has this like massive like watery plumes that shoot up, kilometers into the sort of atmosphere.
Yeah.
I think it's the sort of center of the planet is quite watery, and it sort of heats the water up, sort of in the middle, and sort of spurts it out through the ice. And they plan to sort of send sort of satellites through those plumes to look for life and stuff. So
that's cool.
Yeah, I guess someone somewhere's got to make a budget decision about what to search for.
I'm gonna be honest with you though. I always thought if we were gonna find, like, I thought that we'd probably find evidence for like microbial life on Mars. Maybe.
Yeah.
That's what I was kind of leaning towards.
Yeah, Mars is the big one, isn't it?
Yeah. And then like it's funny that like this has happened with Venus, like something I would never have thought just because it's such a hellscape.
Yeah.
Because like
I think for a long time Venus has been sort of, well, as we said, there's only been one mission actually to it, and it's sort of been neglected because it is considered sort of uninhabitable. But this actually goes back to sort of the main topic, was that we sort of assume we're looking for Earth-like life, and it's possible that things could exist in these vastly different conditions.
Exactly, and like if it turns out that there is like microbial life or something organic on Venus, like imagine what that does to the Drake equation, because it just like that changes like the idea of like a habitable zone for life to exist at all in that place. Maybe it can never get to intelligent life because you're limited to floating in the atmosphere, but you know.
Yeah, I think it would be very unlikely that intelligent life could develop in an atmosphere.
Yeah, can you imagine?
That would be massive. That'd be game changing.
Yeah, literally out of thin air. That'd be bonkers. Yeah, because Titan's another planet as well, isn't it?
Moon.
Yeah, sorry, not planet. Yeah, another moon that we're looking at.
Yeah. Those
photos are cool.
Is that Jupiter or Saturn? I can never remember.
Jupiter.
Yeah.
Jupiter.
Those moons are the ones that are.
Is it Titan and Io that are on Jupiter, and then Europa and that Euclides one is on Saturn, I think.
Yeah, I'm terrible at remembering things like this. But yeah,
some of them are bigger than Pluto, aren't they?
Yeah. But yeah, and also, as you said, Mars is still a massive contender. I've seen things. Obviously, the new mission going there now, with the rover.
Yeah.
So yeah, it's an exciting time for looking for life in our solar system, at least. So,
yeah. Sure. And I think that's pretty much it for this week's episode.
I think it's been a good one.
Yeah. So if you like this episode, give it a thumbs up if you're watching on YouTube, or go and give us a lovely review on Apple Podcasts or Google Podcasts, because that helps with us getting ranked better in the podcast charts, or whatever you want to call it. And if you've got a question or you want to suggest a topic for us, hit us up on Twitter or Instagram, and that should be Infinite Void Pod. And our email is theinfinitevoidpodcast@gmail.com. You can hit me up at Jacob E. Carson, and Matty, I think you're the Matty JMP.
Yeah, the Matty JMP.
And yeah, we'll catch you this time next week.
Yeah.